Back, everybody. So, hey, okay, so I made sure I had this on video yesterday, so I'm going to make sure I have this on video today. Remember how I was talking about the new quarantine rules? Apparently, I was wrong. I talked to somebody else. If you get contact traced within the school, then there's still that mask to stay thing going on. So, like, if you sit by somebody that tests positive, you just have to wear your mask for the next, I think it's 10 days. I don't know. I'm going to stay in my own lane now. I'm just going to teach math. I don't know these rules because they keep changing anyway. So if you have any questions about that, talk to the clinic. Yes?
If someone around you has COVID, can you willingly go home?
Like quarantine,
Even though you're not sick?
But I'm vaccinated.
But I'm not vaccinated.
You're like, oh, I can't. I got to go now. See everybody. I don't know. Again, I'm going to stay in my own lane. If you got questions about that, you ask the office. And I'm going to just teach math. That sound good? All right. So we got 3x minus y is greater than or equal to 5. Now, what's the first step in getting y alone? Actually, I should have prefaced with that. I should have said we should get y alone, right? We should solve this equation for y. Noah? Subtract the 3x. You all right? You guys good?
Yeah.
We subtract the 3x over to the other side. Now I bring down my negative y. Bring the 3x plus negative 3x plus 5. Now, I bet a lot of you got to here. Does anybody know what to do now? Rana? Good. Because I can't leave it like this. I can't leave it like this because y is not completely alone. Y is not alone. So I have to divide by negative 1 over to the other side. And I like what Noah said. He said, wait. We just divided by a negative with an inequality. If you divide by a negative within an inequality, what do? You flip the sign. You flip the symbol. So now this becomes a positive y less than or equal to 3x minus 5. Does that make sense? Now we graph. M is 3, B is negative 5. And then we say rise 3, run 1. Or down 3, left 1. Should my line be dotted or solid? Solid. Should I shade above or below? Below. Be careful here. You look at this sign to tell you that you shade below. Not the one at the top, the one down there. When it's solved for y, when it's fully solved to graph. Questions about that? Good there? Okay. What questions on the homework do we have? I'd like to go over one of the graphing ones, but I'll take any questions that you may have. Noah? Number 5. So let's take a look here at number 5. Remember that this is basically a yes or no question, right? Either it is or is not a solution. Let's plug in negative 3, negative 3. Negative 6 times negative 3 plus 4 times negative 3 less than or equal to 6. Negative 6 times negative 3 is a positive 18. Negative 3 times 4 is a minus 12, which that is 6. Now, is that a true statement? Yes, because there is an or equal to there. So yes, this is a true statement. So we say yes, it is a solution. What other questions do we have? What else do we want to go over? Let's pick one of the graphing ones. Which graphing problem do you want to see? 21, 22, or 23? Nathan?
Can we see 23, please?
Yeah. Let's take a look at 23. The first thing that I've got to do is solve this for y. I've got to add that 4x over to the other side. So y is less than 4x minus 7. Okay, so that means my m is 4 and my b is -7. Let me get a graph over here. You guys might get a kick out of this. You guys know Troy Glasgow?
Yeah.
He talks a lot, right? I had to save this because I have to use it so many times. Oh, didn't go over. Come on. So whenever I want, why is it not working? Come on now. There it is. So whenever I want him to stop talking, I just drag that over and say, "Sure, stop talking."
That's brilliant.
Why is there no?
I want one.
Because he always asks questions. He always asks stupid questions, like he wants to do things in class. So I just say, no. Good. Just be glad about that if you don't. All right. So y-intercept of -7, the slope of +4. So -7. Oh, come on now. -7, slope of +4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And so on. Dotted or solid line? Yeah, I was going to say it's a dotted line, right?
Yeah.
And we know that it's a dotted line because there's no or equal to. Do I shade below or above? Below the line. Less than. Now, if you're ever confused on what's above, what's below, because somebody said, is it left? Is it right? Don't think left, right. Think above or below. Okay? So in this case, I shade below the line. Any point in that shaded region would be a solution. Are there any other questions on the homework that we want to talk through? Yeah.
Didn't you have us do 30 and 33?
33 and 34, yep. You want
Yeah.
to do those?
Like one of those.
You know what? I'll do both of them because they're really similar and they don't take too long. No?
I'll tell you my inequality.
Let me just talk through it. Let me talk through it just so I can explain it as I go. Now, for both of them, I'm going to start with the y value. Now, I have to decide, is it going to be greater than or less than? Remember, shade above means greater than, shade below means less than. Greater than. For 34, less than. And now we have to decide, is there an or equal to? Do I put the or equal to for 33?
No.
Do I do it for 34?
Yeah.
Yes. Now I have to actually make the equation of the line. Okay, I've got my y-intercept of 1. It's always easiest to start with your y-intercept if you'd like. And then my slope, looks like it crosses nicely right there. 2 and 1. Rise 2, run 1. That's a slope of 2. Same thing here. My y-intercept is -2. So I know it's going to be something -2. And then I've got to put my slope in that blank. Okay. Down 1, right 2. Down 1, right 2. -1/2. Good there? Okay. Let me give you guys the guided notes for today. We're going to do a lot of... Yes?
For example, like you just had a straight up and down line, what would happen there?
Then you have to think about left and right. Yeah, right's positive, left is negative. Yeah, that's a good point to bring up. And if you ever had a vertical line, like an x equals, like if you had x is greater than 5, then you would put a vertical line at 5 shaded to the right because it's greater than. Does that make sense? It almost goes back to like a number line thing. Like if you graphed x is greater than 5 on the number line, it would be open circle going to the right. Same thing on a vertical plane. Yep. Okay, so for today, what we're going to be looking at today is a combination of what we did yesterday and what we were working with before. Yesterday we kind of took that sidestep and looked at how do we graph inequalities. We stepped away from systems a little bit. But today we're going to combine what we learned yesterday with our knowledge of systems. So we talked about inequalities, we talked about systems, so today we're going to talk about systems of inequalities. Now, first off, what is a system? Well, a system is just a multiple inequalities, or multiple things going on at the same time, right? So a system of inequalities is just multiple inequalities going on at the same time. That's basically our definition here. A system of linear inequalities is a set of two or more inequalities happening at once. So what does that imply? Well, yesterday we learned that an inequality has shaded regions, and I got a dot or solid or line. So we're just going to have multiple of those things going on the same graph. Okay? The solutions to a system of linear inequalities consist of all the ordered pairs that satisfy both of the inequalities. Both of the inequalities. So on your first couple examples that you have here, we're seeing if this is a solution. Same thing that we did yesterday, right? How do we tell if something is a solution or not? So let's do that exact same thing. Now, here's the catch. It cannot just be a solution of one of the inequalities. It's got to be a solution of both of the inequalities. So let's plug it in. We've got, I'm going to put this one in the top. -3 less than or equal to -3 times -1 plus 1. All I'm doing is seeing if that ordered pair is a solution to the top inequality. Okay, let's run the numbers. -3 less than or equal to 3 plus 1. -3 less than or equal to 4. Is that a true statement? Is -3 less than or equal to 4? Yeah. Okay, that checks out. It checks out for the first inequality. Now we just have to check it for the second inequality. Let's see. -3 less than 2 times -1 plus 2. -3 less than 2 times -1 plus 2. All right, -3 less than -2 plus 2. Well, -2 plus 2 is 0. Is -3 less than 0?
Yes.
Yeah, that checks out as well. It has to check out for both of the inequalities for that point to be a solution. So is it a solution? Yes. We can say yes. It is a solution. It's got to be a solution to both of the inequalities for it to be a solution to the system. Okay? If there's just one inequality that does not work, it's gone, not a solution. Okay? So that being said, let's take a look here at my first inequality of my second example. Example B. Y is less than -2x minus 1. Let's plug in and see if -1 comma 5 is a solution. 5 is less than -2 times -1 minus 1. Just plugged in -1 comma 5 into the top inequality. Ruh-roh. Is that a solution? No. Last time I checked, 5 was not less than 1. So that is not a solution. Do I even need to check the other inequality? No. I can go straight to saying that this is not a solution. Yeah.
So on the test, well, are we just gonna be able to only do one?
Yeah, if it doesn't work for one of them, then you can stop. That's okay. Yeah, and that's a good point to bring up. Whenever we do this assessment here, you need to understand that I've got both. You've got both of the inequalities there. If you say it's a solution, you've got to show the work for both of the inequalities. Okay? You can't just say yes or no. I need to see the work provided.
On topic, but why is there chips?
Oh, it's for I have a challenge match after school.
Oh,
All right, now. So how do we create that solution? Right? How do we find that solution? How do we know what the solution is going to be? Well, I just got done saying that it's got to be a solution for both of the inequalities, right? And to be a solution of an inequality, it's got to be in that shaded region. We talked about that a lot yesterday. For it to be for a point to be a solution to an inequality, it's got to lie within a shaded region. Well, if there's two shaded regions going on, the solution must lie in both of the shaded regions. So let me show you an example, actually 2 examples of a system of inequalities. Yes, you're going to have overlapping shaded regions. Okay? That's what you're looking for. Overlapping shaded regions. Like, take a look at the one on the left side. Again, you don't have this on your paper. I see you copying out of the back of the book too. Yeah, that's really smart. So on the left side there, I see 2 inequalities going on at the same time. I see the dotted red line. Looks like I'm shading below the dotted red line. I have the solid blue line. Looks like I'm shading below the solid blue line. The solution region is the overlapping region inside here. So any coordinate that would be a solution has to lie in the overlapping shaded region. Like, for example, 2, 1 is a solution there. 2, 1 is a solution. You know it's not a solution? This point out here. Even though it's shaded in one region, it's not in the overlapping region. It's got to be a solution to both of the inequalities. I could move that point around over here too. That's not a solution either. But if I put that point down here, now it's a solution. Okay? Same type of thing over here. It's showing you that 2, 0 is not a solution because it's only in one of the shaded regions. It's got to be the overlapping shaded region for it to be a solution to the entire system. So let's graph. Let's graph. The directions here say graph the system and then give 2 ordered pairs that are solutions and 2 ordered pairs that are not solutions. All right, I have y is less than or equal to 3. Ooh, this is our first one that we've had a y, just an only y. What type of line do you think that is?
Horizontal.
It's a horizontal line. Good. It's a horizontal line. Horizontal line at 3. So let's graph it. Dotted or solid line?
Solid.
Solid, because there's an or equal to there. Now, I can use the above or below because it's a horizontal line. Less than or equal to 3, so shade below. Again, I'm going to shade the entire graph because I don't know where the other line is going to end up. I don't know where the other overlapping region is going to be. Now, let's take a look at our second line there. Now, our second line it's already solved for y, so that's good. Our slope looks to be -1. Our b value looks to be 5. Okay? So I'm going to graph this just like I would. I see the slope. I see the y-intercept. I'm going to graph my y-intercept. I'm going to use my slope to generate some more points. Watch out, the slope is negative. Down 1, right 1. Is that slope, is that line dotted or solid?
Dotted.
Dotted line. Shade above or below? Above. Greater than. Okay, now watch this. Smartboard magic here. Look at that. My overlapping shaded region changed color because I used yellow and blue. The green region is my solution region. Okay, the green region is my solution region. So let me ask you. Give me a point that would be a solution. What is a point that would be a solution? Gio?
4, 4.
4, 4 would only be in the blue.
What about 2, 2?
That'd only be in the yellow.
2, 3.
That's where they cross.
4, 2.
Let's go in the region. Yeah. Like in here. Right there. So like, and this is all up for you guys to tell. there could be multiple answers here. So like 5 comma 2, 6 comma 2, 7 comma 2, 8 comma 2, 9 comma 10 comma 2. Okay.
Like going like on the lines.
It depends. If it's a dotted line, you can't use one that's on the line. But if it's a solid line, you can put it on the line. So like
Put it on the board.
4 comma 1 would not be a solution. However, 4 comma 3 would be a solution. Does that make sense? Why don't you guys try graphing this one? Just try this one on your own. All right, here we go. Sorry, guys. All right. So the first thing I've got to do, can I graph the blue line as it is? No, I got to solve it for y. So it's 3x minus 2y is less than or equal to negative 2. I subtract the 3x. So I get negative 2y less than or equal to negative 3x minus 2. We divide by negative 2. Uh-oh, alarms are going off. Why are alarms going off in my head? Because I'm going nuts. Right, I'm going crazy. That too. But mathematically, why are alarms going off in my head? Brianna? Because I'm dividing by a negative. So y is now greater than or equal to 3 over 2x plus 1. Okay, now they're both solved for y. I think my graph is down below here. Yep. I'll graph my blue line here first. My slope is 3/2. My y-intercept is 1. So I'm going to go here, graph my 1. And then my slope is 3/2. Rise 3, run 2. Positive, right? I could also go down 3, left 2. And I make a solid line. Now, do I shade above or below that line? Shade above because it's greater than or equal to. Watch out for that. Again, I'm looking here. Right there. I know I shade above that line because it's greater than or equal to. I go here. Okay. And now I graph my second line. The slope is 4. The y-intercept is 3. I plot my 3 here, and my slope is 4. Okay, I'm off the graph there, but that's okay. I go down 1, 2, 3, 4, left 1. 1, 2, 3, 4, left 1. dotted line for this one. Do I shade above or below that? I shade below because it's less than. I highlight below. And it looks like my green region is my overlapping region again. So 2 points that would be a solution. 1, 3, 2, 5, right? Any point that would be in the overlapping region. All of these coordinates in here would be a solution. Anything that would not be a solution anywhere else. 2, 0. Heck, -2, -2 down there. -4, -5. That would work too. Okay, all of those points would not be a solution anywhere else. Okay. Flip it over onto the back. It's just more examples. We're not going to do all of these. We've got 10 minutes left. Let's do 2 out of the 3. Sound good? Now, let me ask you something. Taking a look at those equations, what do you notice about those 2 inequalities? They have the same slope. What's that mean?
Parallel.
They're parallel. Okay, now you guys think parallel and you guys probably think, ooh, no solution. That's not necessarily true. It can be true, but it's not necessarily true. Let me show you what I mean here. Okay, well, they're both set up to solve for, they're both set up in y equals form already. So I'm just going to go ahead and start graphing. My blue line here, my slope is -2. My y-intercept is 4. Okay. Slope is, or y-intercept is 4. Slope is, oh, sorry, that's a -4. My y-intercept is -2, or, geez, y-intercept is -4. My slope is -2. Down to right 1, or up to left 1 as well. That's a slope of -2. Yeah.
So, if the y is by itself, it's already solved for you pretty much?
Correct. Yeah, there's nothing additional to do beforehand. That's a solid line. And I shade that below. Now watch what happens with my other line. When I go and graph my other line, oops, that's a 3. I'm using the same slope, the down 2, right 1. And this one's a dotted line. That doesn't matter so much. I mean, it should be what it is, but it doesn't affect our solutions as much. But when I go to graph this one, I'm shading above. So where is my overlapping shaded region?
There is none.
There is none. No solution. Okay, there are no solutions to this. You could also use the symbol if you'd like to, the no solution symbol. Now, just because you see parallel lines, don't assume that it's going to be no solutions. Okay? If you want to, go ahead and start graphing the next one. I'm going to do it with you guys, but if you want to get a jump on it, go ahead and start graphing the next one. Like for this example here, let me get my graph. They're already solved for y, so again, there's no additional work to do. My slope for the top line is 3. Y-intercept of -2. Okay. -2, slope of 3. And that's a dotted line. And I'm going to shade that one above. And then my second slope is 3. Y-intercept is 6. Same slope, but different y-intercept. Still a positive 3 slope. Still a dotted line. But guess what? Now I shade below that line. So watch what's going to happen. Are there solutions in this case? Yes. Now remember that the graph is truly the answer. Okay? It's not like I'm saying there's single coordinates or something as the answer. Like, that's just the answer. The graph is the answer to the inequality. There are times where you can write no solutions. But in this case, there are solutions. There's an infinite amount of solutions. I could pick any point within that green region as a solution. Yes?
On the test, are we going to give examples of points?
Yeah. There are a couple questions on the test where I ask you, like, okay, give me an example of a solution. Give me an example of not a solution.
Okay.
All right, that's it for the lesson today. Homework is on page 286. It's 1 to 15 odd. 1 to 15 odd. 1, 3, 5, and 7, you don't have to graph. But 9, 11, 13, and 15, you have to graph. Make sure you show the work, though, for 1, 3, 5, and 7. I don't think there's work for 5 and 7. Definitely 1 and 3. That's the one where you have to say yes or no. Okay. Please don't just look up the answers in the back of the book. Henry.
I'm using it as a guide.
Oh, yeah, right. That's what they all say.